But Simpsons rule is like the trapezoidal rule, it's for determining the area under a curve, and the area rule looks like this. Area equals width over 3, bracket, ends plus 2 times the odds, no, that's wrong already, 4 times the odds plus 2 times the evens. What do we call the ends? What? So if I go H naught plus 4 times H1 plus H3 plus H5 plus dot 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 plus 2 times H2 plus H4 plus H6 plus dot 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 plus Hn, for the number thereof. Okay, excellent. Thank you for that. So that's the formula there. Basically, in short, it is W over 3 instead of W over 2. You can look this up. It's the n values again. It's like the trapezoidal rule. You get your first and your last. But you end up with 4 times the odd terms and 2 times the even terms. There are a couple of little nuances that come in with this. So I'm going to give you a little bit of a lead in about why this works. Not much though. If you want to look up why this works, you're welcome to do that. It might enhance your assignment. It might not be important. It may be more important to look up how this works if you're going to use it in the last modelling question, but you don't have to. So instead, I'm going to just give you a bit of a lead in on it, and then you can do the rest if you want to. So essentially, if you've got a curve that looks like this, here's my, I want an axis system, don't I? Here's my properly good curve. Let's say your curve looks like that, and you want to estimate that area, and you want to estimate the area, say, between this point here, which we'll call B, and this point here, which we'll call A. Your area estimation using the trapezoidal rule, which I'll do in blue, would be to create a number of trapeziums like such. What the Simpsons rule does is, instead of looking at trapeziums, which, mind you, a trapezium is creating a linear function between each subsequent pair of points. Okay? We did the lower, upper, mid rectangles rule, and when we did those rules, that was creating a constant line between points. The trapezium rule creates a linear line segment between points. Simpsons rule creates a quadratic line segment. So what it does is it takes these 3 points here, 1, 2, 3, and as you'll be aware, if you have 3 known points, you can produce a quadratic model for that. So it will then create a quadratic model that will suit that function. You can see here, if I created a quadratic model for this, it'd be almost perfect. If this was something like a periodic function, or in this case, it might be some exponential times a polynomial function or something like that, it's not going to follow a quadratic model, so it won't be perfect. But hopefully when you have a look at it, you can see it will still be better than creating those line segments that the trapezoidal rule uses. So Simpsons rule technically should be better. If you're trying to find the area on a quadratic using Simpsons rule, because it uses quadratics to model it, it should be perfect. That's what should happen. And technically, if you don't find that Simpsons rule is coming out better in your assignment than trapezoidal rule did, then you've either made a mistake, or there might be some nuanced reason that you should go searching for or have a chat to me. That's kind of where we're at. But the most important thing about Simpsons rule, and I need to make this really clear with you because this can cost you in your assignment. Because Simpsons rule requires you to develop a function, a quadratic function in its development between 3 points, you'll notice here that each 2 strips forms a team within Simpsons rule. And then if you want to make a better approximation, you would cut it up into 4 strips, and that would create a quadratic line segment between those 2 triples, that triple and that. That's why this guy gets counted twice, and this guy gets counted 4 times within that. That's why we get that slight difference, but it's a triples again. So 2 strips make a team within the Simpsons rule, which means if you're using the Simpsons rule, you have to have an even number of strips. It doesn't work if you're doing 5 strips. Simpsons rule breaks down, and you could put that into the formula, you'll be able to put that in the formula, but you'll actually get a really inaccurate estimation. And when I say really inaccurate, like instead of being out by 0.1%, you'll be out by 2% or something like that. So it has to be an even number of strips. And I'm going to write that down here. Even strips required. Any questions on that? I'll zoom out. There's Simpsons rule. It's very similar to the trapezoidal rule. When we go on and talk about Monte Carlo method, that's different. Quite different. This is very similar to the trapezoidal rule. If there are no questions, I'm going to spend a little bit of time with you now showing you one way of doing this in Excel. And I'm recording this so you can go back and watch it. Okay? And thank you to Ella for asking me this yesterday. Otherwise, I probably wouldn't have thought about this ahead. But what happens every year is we do something similar to this assignment. It varies each year. But we do require people to use Excel and the Simpsons rule. And I present my idea for this, and people come up with better ways of doing it. So you're welcome to find better ways of doing the spreadsheet. But I really want to stress this to you as well. When you get on to doing your spreadsheet, we are asking that you do things in a not quite elegant, but it has to be a suitable manner to allow you to do quick calculations. So efficiency, that's essentially what we're looking for. But that doesn't mean that it has to be a perfect spreadsheet. This is not a spreadsheet assignment. But if you're doing a Simpsons rule question for 100 strips and you're going through and making a cell where you go add A2, add A4, add A6, add A8, all the way down to add A100, that's inefficient. And that will cost you. You'll lose marks on that. But if you create a spreadsheet where you've got a drag down formula and it works, and the person next to you creates a spreadsheet that's heaps better and it works, well, there should be no difference. If it's a drag down formula and it takes you a minute to change your function or to change how it works, then that's fine. Efficiency is you just have to reach a certain level. It doesn't have to be the best in the class, and you won't get more marks making it any better. So that's what we're looking for. I'm going to show you how to make an efficient Simpsons rule worksheet now. So let's build one. Yeah, you can, yes. So we start with our strip number. So I'll call this the strip column, and we start with the 0 and then 1, 2, 3, 4, 5, etc. Remember, when you build a spreadsheet, it's quite smart. It'll know what you're doing. So if I get bored of typing those and I want to do 20 strips, I highlight 2. It predicts what I'm going to put in next, and usually it predicts right. And you can see my 19s come up there, so I need to go one more, and there's my 20 strips. Okay? Now, let's say if I go back to here, and this is not the best diagram, and this is not the function. I'm going to use a simple function to do an estimation. But let's say that I want to calculate an approximation between, we'll call that 7 and that 3, 20 strips. Okay? And so my function will be, just to guarantee that it's even the whole way, I'm going to use I'll write it down here because it's clearly not our function. Y equals cos x plus 2. So hopefully you'll see cos x plus 2 will look like this. Actually, I might change that. Cos x, let's just do a simple exponential. E to the power of x plus 1 or something. So the simple exponential will look like this. Plus 1 is going to go like that. At 7, it's going to be quite big. So this will be e to the power 3 plus 1, and this will be e to the power 7 plus 1. I've deliberately chosen an easy function, and I've made sure it's all positive. In your task, in your assignment, you might have to deal with the fact that it's some negative and positive components, and you've got to deal with that. So I want to find this area, or an approximate of. So I'm going to go back to my spreadsheet. Because it's between 7 and 3, the first thing I have to do is calculate my width. So remember when we were building our spreadsheet the other day, we built over here a number of cells, or a number of strips, sorry. So I've got a number of strips bit here, and I'm going to do 20 strips. And I'm also going to create an upper bound and lower bound cell there. It's not overly well formatted. I'll give that a capital as well. And I'll just stretch this out. So you should be formatting and making it reasonably neat and tidy. My upper bound is 7. My lower bound is 3. and that means that my W value, my strip width, will be equal to J1, I'll put this in brackets, J1 minus J2 divided by 2, divided by, by G1, which is the number of strips, and that tells me my width will be 0.2. Is that clear for everybody? So that's how we build that. Over here, I want to develop my X values. Remember, my X values are the values along the base of using my Simpsons rule. So it's going to start at 3, it's going to end at 20, it's going to go up by W each time. So I'm going to create that by, I'll call it X values. And I want it to start at 3. So this will be equal to my lower bound, which is there, J2. And I want it to go up by my width each time. So I'm going to make the next one equal to the one above plus my width, which is G1. And just to remind you again, because I want to always use this cell, when I drag this formula down, it will drag the cell reference down here. I have to use the dollar sign. Oh yes, it will be G2, you're right, sorry. So I'll change it to G2, but I want to use that cell, so I have to put a dollar sign so it holds that cell. If I don't put a dollar sign, it will drag it down to G3, then G4, and there's nothing in those cells. So it won't work. So let's just change that to G2. With a dollar sign before the 2, that holds the 2. I put the dollar sign before the G, it means that if I slide sideways, I drag it sideways, that will hold the G column. But I don't care about the G column. I care about holding the G cell. And if I double click on that box now, it will go down to the end of that column. And it should finish, if my spreadsheet works well, it should finish down to that 7. Because 7 is my upper bound. If my spreadsheet doesn't work, then that should be the obvious place where an issue first arises. Any questions on that so far? That's set up there is probably one of the harder things to do. The next bit's a little bit easier, although I have picked a harder function this time. I need my Y values, which are my heights. So to determine my heights, I now need to use my function. So I want to know what is the value or the height of my function at Y equals 2, at X equals 2. And I use my B2 cell here. So I'm going to refer to this one here, X equals 2 cell, and put it into my formula, which was e to the X plus 1. Now you remember that that FX button up there has all the functions in it. If you want to do e to the X in a spreadsheet, you need to use the exponential function, exp of X, which is B2, close brackets, and then I want to add 1 to that. So you can check that in your calculator. If you're unsure, check in your calculator. E cubed plus 1, does it equal 21? I'm sure it probably does, but you can check if you want to. E to the power 7 plus 1 is going to be massive, so I'm expecting this to get quite big. And it gets up to 1097. So probably not as massive as I thought, but again, I can always check that on here just to make sure it has worked. And so I can do my shift E to the power of 7 is 1096.63, and when I add 1 to that, I get 1097, so it's worked. Any questions so far? That's pretty much what we did the other day for the trapezoidal rule. Now this is the step, because the trapezoidal rule is easy. Then you just created a box over here where you said this one plus 2 times all the middle stuff. It's a little bit harder with Simpsons rule. So I've got a formula I developed, and I know for sure it's not the most efficient, but I can't remember the ones that people came up with last year that were better. So here's my one, and you can use it. Come up with one more efficient, that's fine, but it won't actually get you extra marks. This is efficient enough. I'm going to start with I want my n values. I'm happy with them. I don't need to change them. So the 0 and the 20, I don't need to change. So I'm going to leave them there and no change. But I'm going to change these middle values here, strip 1 to strip 19. And I need to separate my odds and my evens. That's the big ticket item here. This is what I'm really trying to do in this case. I'm actually going to need to create a couple more. I'm just going to create a couple more columns. So you can just right click on the F and then insert the column. So what I'm going to do first is get my odd ones out. Actually, no, this is just going to be a generic column. So I'll just call this one XX. And what's going to happen here is it's going to pull out a value if it's even or a value if it's odd. So here's where we get a bit more technical. I'm going to use an if function. An if function will test a cell. I'm going to say if, open brackets, now it's going to do a logical test. I'm going to go to the strip number and I'm going to say test to see if it's odd. So I'm going to put is odd is the function there, is odd is a function, and it will test to see if it's an odd number. Open bracket, and I want to test to see if A3 is odd or not. And then close bracket. Now that returns, this doesn't return a number. All it does is it tells the cell if that's true or false. But what I'm going to do, because I've got this if function at the front, I can select a value if it's true and select a value if it's false. There's lots of ways you can do this. The way I do this is to say if it's odd, let's give it a 1 value. If it's even, so if it's not odd, let's give it a -1 value. So that returns a 1 if it's odd, and it returns a -1 if it's even. Can you see what's happened there? So now that has, the spreadsheet has now split them up. For 20 cells, it doesn't really matter, but if you're doing Simpsons rule to 1,000 cells, that's going to save you loads of time. Because what I can do now is I can call out the odds and the evens. Now, another way you could do this is you could just make that a half, which would fix the problem we're going to get in a minute, but I'll leave that up to you to deal with exactly how you do it. So what I'm going to do now is I'm going to get my odd column. So here's my odd column, and here's my even column, and then I can sum them up at the end, okay? So my odd column, I want to call out all the ones that have a 1, but not the ones that have -1. There's lots of ways you can do it, but the mathematical way you can do it, which is quite quick, is to say, well, let's get equals this value plus 1, and I'm going to put a bracket around that because I'm going to multiply. I'll put a bracket around that value plus 1, and I'm going to multiply it with the star symbol by the y value, which is what I'm actually after. They're my heights. And it returns out. Now, watch what happens when I drag this down. What I should get is an interlacing bunch of values and then zeros. Because in this cell here, I've done that plus 1, which is 2. 2 times this gives me double that one. Here, I've done -1 plus 1, which is 0, times that, it returns 0. So you see how it's now returned 0 for all my even ones, and it's returned the double of that for my odd ones. Can we see that? Okay, so I'm happy with that. Now I've got all my odd ones, but I've got them doubled, which is fine because eventually I have to do 4 times my odd ones anyway. So we'll deal with that in a minute. In my even cell, I'm going to go equals, and this time I'm going to use a negative because I know I end up with a negative, and I'll show you that in a minute. Negative, this cell, D, -1, and I'm going to multiply that by my y values. Now you'll see for my odd values I get 0, but this time for my even values I get the numbers that I want. So because in here I've said D4 -1. So I get my D column, I subtract 1. If it's already a 1, it becomes 0, which returns a 0 here. If it's a -1, it becomes -2, and so it doubles it. I'll put a sneaky negative at the front so that -2 becomes +2. How's that? It's on video. You can just go through and copy my video, but hopefully it's making sense. And it hopefully shows you the power of Excel, because you probably haven't done a lot of Excel at school, but ultimately most careers, people end up using Excel, and it's a really, really powerful tool. You can do lots of stuff. Ultimately, if I'm using it, I'm just sitting going, I need to do this, and usually can find a way. There's a way somewhere. Anyway, I've got this. Now I'm going to make one slight change to my even column, my odd column, sorry. Because remember, if we go back to the formula, I need 2 times even, but I need 4 times odd. So in my odd column, I'm going to make this change. I'm going to make that 2 times that, and I've done that symbol. 2 times that, and it will now double that. And I'm going to drag that down to there. And what I can do now is, here, I can have, or wherever I want. In fact, I might do it over here and just have total area cell up the top here. So we'll just have an area cell. My area is going to be equal to my width over 3, which is that value divided by 3, times by, and in the brackets here I have my n values, which will be this one, plus this one, plus, and I'm going to use a summing function. So I'm going to do the sum of all of these numbers, they're my odds, plus the sum of all of these numbers, and those zeros cancel out my odds in this case. I'm going to close that bracket and press enter, and that gives me my area approximation, which for a moment I was a bit stressed for a moment because I thought, oh, that's way too small, given this is 2,600 already. But actually, width divided by 3 is quite a small number, so there's a small multiplier at the front, and that's my area. Do we have any questions about that? I can adapt that spreadsheet quite quickly to make it for 1,000 strips. I have to change this formula. That all works, but I have to change this formula, and then I have to go in here and do a lot of dragging down and just check the clarity of it all. Now, this should be a very good approximation. So the last thing I want to show you is this is where I go to do my work on integrating. So I'll show you that you can integrate in Desmos quite easily. Desmos is one of those tools where when you open up, it looks like you can just draw some graphs, but it's actually really powerful. You can do lots and lots of stuff in it as well. So if I go on a Desmos screen here and just type integrate, INT, it comes up with an integral sign. I can go between 7 and 3 of e to the power of x plus 1. Now, Desmos will be a bit funny if you don't put brackets around the whole integrand, the thing inside the integral sign, dx, and it gives me back that integral. I think it's quicker than most of the other solvers online. I can just type that in, 1080.55. And if I go back to my spreadsheet, I got 1080.56. Now I can make that comparison and talk about it. Any questions on that?